Hello all, welcome to a project Water Potability Prediction. So the main aim of this project is to predict the potability of water, that is the water is safe to drink or not using machine learning and auto machine learning techniques. Now you might be wondering what is this potability? Potability or potable water is nothing but drinking water. It comes from surface and ground surface and is treated to levels that meet state and federal standards for consumption. The water that you drink is known as potable water, and if the water is drinkable or not, that means that is the potability of water. Water from natural sources is treated from microorganisms, bacteria, toxic chemicals, viruses, and fecal matter. Drinking raw untreated water can cause gastrointestinal problems such as diarrhea, vomiting, or fever. Clearly, if you'll not drink clear water, it will create problems. So, in various of the houses, there is a chance that the water is not potable or water is not that clean enough. So, we'll be building a machine learning model which will help us in predicting, okay, the water is clear, potable or drinkable or not. So, there is a problem statement given from Kaggle only. It is stated that contaminated water and poor sanitation are linked to the transmission of disease such as cholera, diarrhea, dysentery, hepatitis, etc. Absent and inadequate or inappropriately managed water and sanitation service expose individuals to preventable health risks. This is particularly the case in healthcare facilities when both patients and staff are placed at additional risk of infection and disease when water, sanitation, and hygiene services are lacking. So this was a problem statement, or this was the problem which was stated in the Kaggle. So we decided that we'll build a model which will help us in predicting the potability of water, that is if the water is drinkable or not. In that we'll be using different ML and auto ML algorithms for prediction. So now if in at auto ML algorithms, let us discuss what auto ML is. So AutoML enables developers with limited machine learning expertise to train high quality models specific to their business needs. Basically, AutoML automizes all the model development part. In this library, in this section, we'll be using the H2O AutoML. What is H2O AutoML? H2O is a fully sourced, distributed in-memory machine learning platform with linear scalability. H2O supports the most widely used statistical and machine learning algorithms, including gradient boosting machines, generalized linear models, deep learning, and many more. Basically, all the models which you use in a machine learning, all of the models are there in H2O AutoML. It will automizes the whole process for us and give us the best results. So let us proceed that what will be the timeline of our projects. First, we'll be doing the data analysis. Then we'll be doing some feature engineering or data pre-processing to make our data ready for model development. Then we'll be building models using ML and DL. Then we'll be using H2 AutoML for predictions, and we'll compare both of the models. So let's begin. Hello all, welcome to our project in the notebook section of drinking water potability prediction using ML and H2O AutoML. So now I have already told you the context behind this project, that what is potability and what is potable water, and what is the reason behind this project and what we'll be doing. So I have told you that potable water is nothing but drinking water, and potability of water means the water is drinkable or not. So the drinking water potability file contains 3 to 76 different water bodies. Okay, that means it contains 3 to 76 different information about. Sorry, it contains information of about 3,276 water bodies. Okay, so we'll be using different ML models and H2O AutoML library in this project to predict the results. Let us understand the timeline of the project. First, we'll be doing the importing our libraries data sets. Then we'll be doing data analysis and pre-processing for that. If required, we'll be doing some feature engineering. Then after our model is ready for model development, we'll be using different ML algorithms to predict. Then finally, we'll be using H2 AutoML, seeing how we can do the model development or automate it. So the first thing is we have to import our libraries. I'm importing NumPy, Pandas, and Matplotlib C1 for visualization, train test split for basically pre-splitting my data. The very first thing is you have to load your dataset. So now in order to load your dataset in Google Colab environment, you first have to import your CSV file into your Google Drive. Then you have to mount your drive in this Colab environment. You can mount your drive using this button. When you click on this command will appear, execute it. It will basically ask you to provide permission to access your account data. So you'll go to this link and it will tell you to sign in, select an account in which you have uploaded that CSV file, then click on sign in. then copy the link provided. When the you just this is an authorization code, paste that code here. It will take 5 to 6 seconds to get executed. Then it will say mounted at content or drive. That means see mounted content drive. That means my drive is mounted. My Google Drive is mounted in this environment. When I'll see and go here, see drive here, then my drive. Now what we have to do? I just have to find my file which I just imported in my Google Drive. That the name of that file is water potability, drinking water potability. Okay, this is my file. I just copy the path. I'll paste that path here. Then I'll read that using pandas. So this is my potability. This is my data. Okay, this is my data in which different pH values is given. Hardness of water is given. Solid, chloramine, sulfate, conductivity, organic carbon, trihalomethanes, turbidity. That is given, and potability is my dependent variable. Okay, so these are all my data, and this is how we can import our data in libraries. In the next section, we'll be doing some data analysis and uh, pre-processing techniques along with model building. Hello all, welcome to the next section of this project. In the previous section, we had the intro of the problem and we saw that how we can import libraries and dataset in Google Colab. So now in this section, we'll be doing some data analysis. We'll be doing some data analysis part. So the first, let us have a look at our data in that various variables were given. That is the pH, hardness, solids, chloramine, sulfate, all of these things which are necessary to see okay if the water is potable or not. And if it is 0, that means the water is not potable. It is 1, that means the water is safe. Let us have a look at the data. What is the shape? As mentioned above, there are around 3276 data rows. And if we want to see the data types, all of them are around float. Only the potability is of integer type. Then we'll have non-unique, which means that we'll see that. Okay, so as I mentioned, this is of no use because we have no categorical data. So all the numerical data, so all the values will be distinct. So now let us do some data analysis part. So first, what we'll do, we'll see the count plots to see that if the data is imbalanced or not. But we see that data is pretty not that much imbalanced with a ratio of around 65 60-40 ratio. So around one per the less is the part is the one, which means the water is potable is less, having a less count, while the what 0, that means the water is not potable, is having the highest count. Which this shows us that the data which we have is mostly of the water sources which are not that good or which are not good for drinking water. So let us have a look for our null values. So there are three columns have null values, that is the pH, sulfate and trichloromethanes. We'll remove these null values again one by one. Now what we'll do, we'll plot a distribution plot. Then we'll say that okay, from what these are for what how these values are distributed and how we can replace them. First, going on with pH, if you'll see the distribution plot, so this is perfectly normally distributed. Now what I'll do, I'll just replace this non values with the mean. Okay, I can replace it with the mean, it will be perfect. And now if we'll go to sulfate, if I'll go to sulfate, and the sulfate same is also the same, the I can also replace, then I can replace this also with mean values. Then for trichloromethanes, the distribution plot is also the same. We can replace this with the mean values. So we have replaced all these with the help of mean values. Now I have written here several different functions, but what you can also do is you can write a for loop. For I in null I have created a list for these two, then I'll say SNS.distribution plot. You don't have to write this again and again, it will just plot the curve for whole three at the same time. You can use these little hacks to make your code shorter, but in order to make you understand, I have used this again and again. So now the next thing is, let us see if there are any null values left. So there are no null values left in our data set. So now what we'll do, we'll just plot a pair plot. So if you don't know what is a pair plot is basically a multivariate analysis feature, in that it will create many different number of plots on the basis of different features. Basically it will create different correlation plot. It will create each and every plot with each and every feature with two different feature. You will find a plot of every two different feature. Okay, you will see how this is found out in the SNS library, that is the C1 library. You can find it there. So now the next thing we'll be doing after plotting is we'll be plotting some box plot. So let us see, the our pair plot is almost completed. It is taking some time because it is a very huge plot and a lot of calculations are to be done and a lot of visualization are to be done. So it can take a minute to get performed. If, depending on your computer, if your computer is slow, then it will take more than a minute. As you can see, so much RAM is used. See, around the RAM usage was very much. Okay, the very good thing about Google Colab is shows you the usage of RAM. So it was at peak. I think the it has completed. Then it will be shown any moment now. So now it will see, now this is my pair plot. As you can see how much big this plot is. Okay, each and every variable is here in the x-axis and y-axis. Various scatter plots are given and various distribution plots are also given. Okay, तो बस ठीक है. So we can find out देखे how these variables are distributed and how these variables are not distributed. So, but according to this, we cannot find much information because of the scatter plot is almost our data is almost messed up, pretty messed up, because it is always mixed. Okay, we cannot find out such conclusion because the data is quite mixed in a scatter plot. So we'll just move to plotting a box plot in the df dot columns. In that we'll find out what are the outliers and how these data are distributed. So now in the very first thing, the first is pH. In that we see that this has many number of outliers. The maximum value is around 10 and around 4, but there are a lot of outliers also in pH value. The similar goes for hardness also. The mean value is 200, maximum is around 220 and minimum is around 170. And the solids is also the same. Outliers are there, chloramines are there, sulfate is there, conductivity, organic, there these are having less outliers. So now what you can do, you can either remove these outliers. Okay, you can remove these outliers. Obviously I have not done it, but I'll tell you how you can do it. What you can do now, by plotting a box plot, you have known that what is the 100th percentile and 0th percentile of this, right? Okay, beyond this the outlier is formed. So in pH you can leave these outliers because these are very close to the 0th and 100th percentile. You can only remove the outliers below 2 and above 11, I think. Okay, above 11 you can remove this. You can write a simple command. Okay, give me only those column in which pH value is less than or greater than 2 and less than 11. Similarly for hardness also, give me only those values in this pH value is less than 100 and greater than 100 and less than 250. Okay, so this is how you can clean your data, but I have not done it, but you can do it on your own as your assignment. So this was our outlier analysis, and the next is the most important is the heat map, the correlation. We have find out that how these correlations, how these data are related in the form of correlations. So if it is negative, that means it is negatively correlated. That means if that variable increase, the another one will decrease, and the positive is the vice versa. So now, but this is up. This can take up time to understand. So in order to visualize it, we'll plot a heat map and we'll give that data to there. Then we'll have a proper beautiful heat map based on the color. So now in this we are having that, okay, how our data is distributed, and in this also we can see that none of the data is negatively distributed, right? The column is still 0 only, because those data only tells us about how much the water, that the more that data information is, the more the potability or the more the hardness of the water will increase. That's why it has no negative correlation, many very few of them. But also we found that these data is not that much correlated, because the color is always in the dark scene, which means below 0.2. So we'll see that the data is not that correlated with each other. So this was the data analysis of our different variables and all the things. You might have had an idea how we did that and what all things we did. We saw that how our different plots are there and how our data is distributed. How our which we see that our data is not that correlated. That's why the scatter plot is also so much ununderstandable, right? So the next thing we'll be doing is we'll be doing some feature engineering techniques to make our data more good or more, and then we'll scale our data to make our data ready for model building. Then we'll see the predictions. So let us move to the next section. Hello all, welcome to the next section of this project, that is the feature engineering part. Now in the previous sections we have done the data analysis part. We saw how different data correlated and all of these things. Now we'll be seeing some feature engine. In this feature engineering section, we'll be seeing the feature importance. Okay, which feature is important. Okay, in the correlation part, we did not had much correlation, so we couldn't find out. So what I did, I decided to use a feature in extra tree classifier, and I'll try to plot a feature dependence plot. For that, how I'll do it, I'll just say from sklearn or in symbol, I'll import extra tree classifier. Then I'll just split my data to feed my model. Then I'll import a extra tree classifier. Then what I'll do, I'll just define my model and fit it. Okay, what extra tree classifier do? Extra tree classifier provide us the feature importance. Now if I'll say print extra ext dot feature importance, that means there are around 1 2 3 4 5 6 7 9 features. Okay, the nine importance are there. Now if I want to see it in a bar graph, so I'll just plot it. I get it in a series, then I'll sort the values, then I'll plot it. So now it means that we see that the pH and sulfate are the variables which are the highest, which have the highest importance, and turbidity have the lowest importance. But there is not much difference in the all of them, which means that all of these data are approximately important in prediction. So now if we look at our data, so if we have a perfect data, but we see that there's data are on very large, and that is the hardness derived from 204 to it can range to 100 solids. This range is from 20,000 to around 17 to 15,000. Range is very large. Okay, so this is not good for a model. So what we'll do, we'll scale down this data to minus 1 to 1. We can also do this using min-max scaler, but I'll be using standard scaler. You can use min-max scaler also and see which model is providing better results. So I'll just import min-max standard scaler, then I'll fit transform my data. Now if I'll see my scaled, it will give me an array. It will give me an array. So this is my array of my data, but I want it in a data frame, so I'll just convert it again into a data frame. I'll take columns from the x dot columns. So this is my perfect X scale data set, which is I have written scale DF. Then I'll just split my data from scale X scale DF and all of these things. Okay, I'll just split my data. So what I'll do, I have written here wrong. I'll use scaled DF is my X and Y is my data which I have taken. Okay, I'll just split my data. If I want to see the shape, xtrain dot shape. So this is my 2293 is my shape, because I've used 30% train and 30% test and 70% train, and my x test is shape is around 983. Okay, so now this was our now our model data is ready for model development. Now which we'll be doing in the next section, we'll be building models with the help of machine learning. Then we'll proceed to automated machine learning. Hello all, welcome to the next section of this project, that is the model development section. So now in the previous section we have seen that how we have analyzed the data. We saw how many null values are there. We handled with the null values. There were no categorical variables, so there was no need to handle these. I show you the outliers. We did the outlier analysis. I also told you how you can handle those outliers. Then we standardize our data, we splitted our data. Now it's time for our model development. Now if you want to see your data how it looks like, so if you want to see your train data, so this is your train data. Okay, so this is your train data, perfectly scaled from -1 to 1. Okay, so around it is perfectly scaled to lower values. Okay, there is not much difference, which will be good for our model development phase. So now we'll be using three models. One is the logistic regression, second is SVM, then random forest. I'll just import the all the matrices and the models earlier, so that we don't have to import it again. So now using the logistic regression. I hope you're all familiar with the logistic regression. Logistic regression is basically a regression technique, but it is mostly used for classification problems, because it is best suited when an output is in the form of 0 or 1, which is probably the case here. So we'll be using a logistic regression. I have defined the model. I have fitted it. Then I am printing it. Okay, I am storing my xtrain print results, print xtrain hat and y test hat. I am printing my test results. Now I have written a code here in which I have to I am taking my all the matrices. Okay, I am taking a classification report for test performance. I am taking, give me the classification report of y test and y test hat, that is I predict what I predicted. Okay, I am also taking my ROC AUC score, area under curve score, then I am plotting my confusion matrix, then I lastly accuracy score. So let us see what are the results. So the precision is around 0.62, recall is around 0.01, for then F1 score is 0.77, ROC score is 50.2, confusion matrix is this. As we see that we have no false negative here. Okay, false positive and false negative. There are a lot of false positive, but there is no false negative. True positive and true negative are there. Now accuracy score is around 62% test data. As we see that logistic model has not performed had not performed that good with an accuracy score of around 62% only. So now that we'll see that how SVM model performs. So SVM model, if you are familiar with the SVM model, SVM models are also used for classification. They basically create a line, support vector machine. They create a line between two variables and split the data into two parts. That is the 0 and the 1 output. I'll do the same. I'll define my model, fit with it. Let's see what is my test performance. So in this also I am getting a recall of 0.93, precision of 0.68, for 0 and for 1.71, precision 0.28 recall. Then if I'll see ROC score, it is much better than it is 60.3. Okay, my test data accuracy is increased around 68.2, which is better than the logistic regression. In this confusion matrix also my true positive, true negative is increased, but my true false positive are still much more. Okay, so this is my support vector machine. Now I'll see that how my random forest model performs. Okay, random forest is basically a collection of different decision trees which creates different decision trees, and see how it works. So now if after predicting with random forest, we'll see that ROC score is around 61% and confusion matrix is around the same also, but the test accuracy score is around 68.2%. So after comparing all of these three models, we find out that none of these models are performing that much good that it should perform. Maybe they'll perform if we'll do some hyper tuning it, we'll use the right parameters. Right now they are taking their default parameters. Now, but if we'll take the right parameters, maybe they'll perform better, or we can use some other different models. So there is many much of hustle, right? I have strictly purposefully used this model. I have not done hyper tuning to show you that how good auto machine learning is, because when we'll be using automated machine learning, we don't have to worry about all of these. Okay, this will be done automatically. Now we'll be seeing that in the next section. So let's proceed. Come to the final section of this project, that is we'll be using automated machine learning. So now let us have a recap of what we have done in the entire project. The very first thing we did, we understood the problem, that what is the potability of water and what is a drinkable water, and what are the things. Okay, then we imported different data. We see how we can import the data in Google Colab environment. Then we did some research in our data. We did some data analysis. We did some data pre-processing part, in which we removed some data. We saw different outliers. We removed man values, all of these things. Then we did the data pre-processing, standardize our data, splitted our data. Then we used three different machine learning models, that is the random forest, SVM and logistic regression, in which we saw that none of these models were performing that good. They were the accuracy is around 70% only, which is not that, which is a decent accuracy but not a good accuracy. So if we would have hyper tuned the model, maybe they would have performed better, or we would have used a different model, it would have performed better. So now in this section we are seeing that how we can erase this problem or ease this problem with the help of H2O. So AutoML, I have already told you that AutoML automizes all the model development C part. Now H2O AutoML is a fully open source distributed in-memory machine learning platform with linear scalability. H2O supports the most widely used models, which are the GBM or generalized linear models, deep learning model, and many more. All the models which we used above are all present in H2O model. So let us see that if our model choices was right in the previous section, and see what this model does. So in order to install your H2O AutoML, you have to write these commands. If you want to do it in your Google Colab or Jupyter environment, you can directly write this command and take a exclamation mark. So first you have to install request, then tabulate, then there is one library you have to install it required for H2O, another library future you have to install it for H2O, then it will install H2O. So now make sure, after I have already installed it in your in my computer, that's why it is saying requirement already satisfied. I am telling you for all the only for sake of you. So now the make sure when you install these, when the installation is complete, you have to basically restart your runtime. If you will not restart your runtime, what happens is the H2O will not run, because it will not read that libraries. In Google Colab, what happens, unless and until you do not restart your runtime, the new libraries which are given are not the new libraries which are taken are not installed, are not read. Okay, so now I have already installed that, why that means I may not be able to, there will be no need. Okay, see, there is no need for me to reinstall because I have already installed. But if you have installed it for the first time, you must restart your runtime. You must restart your runtime in order to read it. So now I use the command h2o.init. This is basically to make sure that no prior instance is running. I've imported h2o, then h2o, then I imported h2o automl. Then this is all the information about h2o, different things which was written: free memory, total cores, allowed cores, Python version which is used, the extension, what are the different extensions. These are the all the different things. So now the very first thing is to load our data. Then to load our data, what you have to do, you have to use h2o.import file. You cannot read from pandas. In this you have to use h2o.import file. The function will be same. You just have to copy the link and paste it here in h2o.import file. This is my file. So now what we'll do, we'll just, also H2O AutoML can do all the pre-processing techniques. The when we did earlier, we don't have to do that here. Okay. The very first thing is we'll split our train and test data with the ratio 80-20. So now we'll define the variables, how, what are our dependent and independent variables. Okay. So now we'll define our model. In that we'll do what we'll do. I am saying AML is a variable I defined. H2O AutoML, I am saying max runtime second is 300. Max runtime second is 300, and maximum model use maximum model 10, and seed is equals to 10. So there are many different number of parameters, but I have not used here. There are many different number of parameters which can be used. So you can look at the H2O AutoML documentation and find out, okay, what are the different things you can use in H2O AutoML. But here I am providing the model, fitting model. I have executed it. Might take, I have taken 300 seconds. Okay, so it might take 300 seconds or less to compute. So X is my X, the all the df dot columns. Y is my potability. In that df dot columns, I remove the potability, and I have given take data from this df train which I have taken. Okay. So now as you can see, it is install taking and checking all the models. First ensemble model, it is taking, checking XGBoost model, another ensemble model, all of these things it have taken, and then these are the different scores which are given. But now I can see that which model finds me the best. So we'll use the leaderboard command, aml.leaderboard. So now it is giving me all the different models which were used. One is the stacked ensemble. Basically stacked ensemble is the compilation of all the models. That is the best thing one you can do. In order to use stacked ensemble in normal machine learning, you have to write a lot of code, but here it is done in 1 second, in single line of code. Okay, stacked ensemble are all the three or four stacked ensemble models. Then XRT, GBM, DRF, GBM models. Then if I can, what I'll do, I'll take a list of all these model IDs. Okay, I'll store them in a list called model IDs. Then I'll say, okay, model leader dot model perform aml dot leader, matlab, which means that the leader which is having the highest score predict the results with my test data. Predict the results with my test data. So it is given me all the reports on test data, reported on test data, MSE, RMSE, R square, okay, R square, and all of these things, AIC. So now what I can do, I can get this model. I can get this model. This is the model details. This is the model detail. I said that, okay, wherever you are finding stacked ensemble in that list, give me that model. So it is giving me top two models. Then I'll say that I am storing it into output. Then I'm finding out the parameters. I am finding out the parameters which were used in that model. So the documentation of H2O is that much good that it is giving you each and every parameter which was used. Okay, all the different parameters which were used to, so that you can explain your model in a very better way. That means a very good documentation. Meta learner algorithm, meta learner fold algorithm, fold column, n fold parameters, all the different things, right? So now then you'll see that what is the aml.leader. Again, I'm checking, okay, what is my leader, what is my best performing model. This is my best performing model, these are two are my leader. Okay, so this is my train data, this is reported on cross validation data. For the first thing is reported on train data, another thing is reported on cross validation data. So now if I want to predict, I'll just say y predict aml.leader.predict. I'll say the predictions, I'll see the predictions. So these are the my prediction. These are stored in the probability format, which means that if the probability is greater than 0.5, then it is a 1, else it is a 0. 1 which means that the water is drinkable, and 0 which means that water is not drinkable. So this was all about the H2O AutoML. Not all about, there is much more to it, but this was the basic or the everything you need to know. There are many extra things. You can tune your model, you can try different things in the H2O by visiting their website, see their documentation, and find out, okay, what are the different things, what are the things you can use, all of these things. I'll be providing you this notebook and the data along with it. Practice it with this notebook and make some new changes which I've done, like do the outlier analysis on this and all of the other things, and make some in ML also, try some different models, try to do hyper tuning with grid search CV, randomized search CV, then compare this with this, try to see in this, try to tune this model in this, then you will find out the major difference, okay, how these things works and what is the best among it. So I hope you all understood, and happy learning. Thank you.